Hello and very good morning for uh, doctor. My name is Muhammad HAKIM bin NADZRUDDIN. My metric number is BE30136, and today I will talk about the methodology for our group project for assignment 2. And this is the full block diagram circuit for our project, and we add some extra component for add some features in our project system. So first thing first, we have LPC 1768 for our microcontroller that control our system, and we use 1, 2, 3, 4, 5, 6, 7 pin in LPC 1768. So the first pin we use P1 pin 1.30 for our start button, and P0.0 for stop button. This start button will, if we press the start button, and the system will start working immediately, and then if we push the stop button, the system will stop working immediately. So in this block, we have three components, which is cooler, heater, and temperature sensor. So we use the LM35 for our temperature sensor. So LM35 we are connect to pin 0.23, and for the heater we connect to pin 1.20, and for the cooler we connect to pin 1.18. So if the condition in this water manufacturing plant is the temperature is below than 50 degrees, the heater will turn on, and the cooler will turn off. And if the in this area the temperature is higher than 70 degrees, the heater will turn off and the cooler will turn on. If the condition is between 50 and 70 degrees, both of this component will turn off immediately. And then we add some features, which is LED. This LED will indicate the condition for our manufacturing plant temperature. So we use PWM duty cycle to control the brightness of this LED. If the temperature is below than 50 degrees, the duty cycle of PWM is 10%, and the brightness of this LED not bright because of the duty cycle of PWM is 10%. So the gap of the gap for LED blinking is high. The gap is big, and then that become the LED not too bright. So for the condition, this manufacturing plant is between 50 to 70 degrees. The PWM duty cycle, we are using 50% of PWM duty cycle, and then the gap of the blinking LED will more than previous condition, and then the brightness of this LED will become more bright from previous condition. And then for the condition when the manufacturing plant is temperature is more than 70%, the PWM duty cycle will become 80%. So 80%, the gap of blinking LED is faster, and then the LED will become too bright. And then all this data will transfer to computer using UI serial. So this computer will display the data that we get from this system. So that's all for the methodology. And in this assignment project, we are use micro microvision for our software to simulate, not just to simulate and uh, to complete the coding for this assignment. So that's all from me. So thank you.
Hello, my name is Muhammad RIZUWAN page OTHMAN with number metric CE200226. Next, I will be discussing our flowchart. Flowchart are diagrams that show steps in process. The shape that are simple and visual will ease our understanding of the program that we are going to build. For our flowchart, first we going to start initializing the program and ready for execution. If we start the program, it will read the analog input from the pin that we decided to place on our sensor at LPC 1768. The analog input, which is the temperature, must be converted to the voltage using the formula temperature divided by 10 milli. If the sensor detected that the water temperature is less than 50, it will turn on the heater and while the cooler remain off. If the water temperature is larger than 70 degrees Celsius, it will turn off the heater and while the cooler will be turned on. If the water temperature does not meet the required both conditions, both heater and cooler will be turned off, thus causing the water to maintain its temperature between 50 to 70 degrees Celsius since it is our objective for the system. That's all for me, thank you.
Hi, Assalamualaikum. My name is Muhammad IKMAL bin FAIZAL, CE200146. So today I would like to share about our coding. So first, here is where we upload, we declare what we want to use in this program. So this is what we use. So as you can see at line 8, we have analog to digital converter, and here we have UART. So here we have delay, timer, PWM, and GPIO. GPIO is a general purpose input output. So next here, so here at LPC GPIO 0, we declare heater and cooler at pin 18 and 20. So FIO CLR, if where we want to set that at the default condition, the pin is off. So here where we set up that the system wait for the start button. So there is our coding. So this is the formula that we use to convert temperature to volt. So as you can see here, if the volt is less than 0.5, the heater will on and the cooler will turn off. So as you can see, if we want to on the heater, so we use this pin here, which is heater on pin 20, and FIO set is to declare the system will turn on. So to turn it off, if FIO clear, CLR, and here is the pin for the cooler. And the duty cycle for this system is 0%, and the LED will turn very low. So if the volt is more than 0.7, what will happen? The cooler will turn on and the heater will turn off. So we set it here, FIO set and FIO clear, and the pin is here. How about the duty cycle? So the duty cycle will happen 80%, and the LED will have the high brightness. So what if the water temperature or the voltage is between 0.5 and 0.7? So both cooler and heater will turn off. So if you can see here, the pin here, and both is FIO CLR. So the duty cycle is 50% and the brightness will be moderate. So next, so here, so and here as you can see we do this coding. So at here, the off heater and cooler, so we set the cycle 0%, low brightness, clear the integer. So here is our coding, and here, so here is our PWM setup. So as you can see, we set the pin function of PWM 1.1 at port 2 pin 0. So here PMW1 output is enabled, So here 1 microsecond resolution, and this coding, we reset the PWM MRO and TC if it match. So we set the PWM cycle at 10 millisecond. So the duty cycle is 0, and here is the latch value and enable counter to the PWM modes. So that's all from me. So my friend will continue our presentation. So thank you.
Assalamualaikum, my name is ASSIGNMENT2 bidang ZAIDIL, matrix CE2000128, and I will continue the presentation for the simulation of the assignment 2. So we can simulate this coding by pressing the debug button. Once you are in the debug button, as for example is in this one, you can go to the peripheral and then you can add the GPIO fast interface port 0, and also you can add another peripheral which is GPIO fast interface port 1 as for the input and the output. So basically, once you have these two GPIO port, you can also take AD converter out, which is the analog to digital converter, and you can set up the logic analyzer right here as shown. So for this one, this port 2 is the output for the LED. So basically the first port is gonna be the PWM, and this one is gonna be the address of the PWM. As for example, I'm gonna run the simulation. Just press this button, and then you can see it running, but it doesn't have any value since we doesn't put any condition. As for example, I'm gonna choose 0.4, which is equivalent to 40 degrees Celsius. After I've done putting the value of the 40 Celsius inside the analog to digital converter, I'm gonna press the start button, which is on the pin 30 on port GPIO 1. So I'm gonna press this button, and then I'm gonna press it again, and we can zoom all or zoom out, and then as you can see, for the temperature below 50 degrees Celsius, which is, as for now we choose 40 degree, we have 20% duty cycle as shown in this figure, and also we have the address of this LED output, which is at 0 times with 01F0. So we're going to the next example, which is on when the temperature is above 70 degree. As for example, we choose 80 degree, which is equivalent to 0.8. And then you can see the changes in the duty cycle here. So basically, it's gonna become 80%, and the address is 0 times 03 E0. And then the next step is, the next condition is when the temperature is in between 50 to 70. So I'm gonna choose 0.6, equivalent to 60 degrees Celsius. So I'm gonna run. As you can see here, it will become 50% duty cycle. That's all for me. Thank you.
Assalamualaikum, my name is KHAIRUL IBRAHIM. My number matrix is CE20060. So for my part, I will explain about the simulation. So first, for below 50 degrees Celsius, so I'll put 0.3 here, which mean if we convert it, it will be 30 degrees Celsius. And then we run it. So after we run it, we will get the P18 is 0, which is off, and P20 is on. So which means that the temperature is too low, so we need to rise the temperature higher, between 50 to 70 degrees Celsius. And then for the second condition is in between the 50 and 70 degrees Celsius, which is I'll put 60 degrees Celsius, and then we run it. Okay, for 60 degrees Celsius, the pin 18 and 20 is off, which is 0, because that's the temperature, water temperature that are in the range. So this is the duty cycle, which is 50% duty cycle, and for the PWM signal, this is the address in binary 240. For the third case is greater than 70 degrees Celsius, which is 80 and 90 degrees Celsius. So as you can see here, the pin for P20 is off and P18 is on, because the temperature, the water temperature is too high, so we need to on the cooler and off the heater. Is the duty cycle for 90 degree, which is 80% duty cycle, and this is the serial line for PWM signal 116 in binary. And then for the next is the interrupt. So when you press the 0 button, it will interrupt the signal. Yeah, as you can see here, the signal is being interrupted, so it will stay at 0 value. So that's all from me. Thank you.